And the second is what's the proposed solution, and then what sort of experiments I've done with this, and the result, and some conclusion. Okay, so for the problems, right? As we all know, hacking is on the rise. People are trying to, the script kiddies try to exploit, basically doing, exploit the weak passwords from SIP accounts, right? And then once they broke in, they will use that to make international calls and then rake up some, big bills, right? So, and then for enterprise, usually they're kind of short-handed, because for the CISO out there, Chief Information Security Officers, their rule of thumb is, let's say they only allocate about 10% of the staff to be the security, IT security staff, right? And then out of those 10%, can you guess how many percent know actually the SIP security is even less, right? So what end up happening is, the operation have to take care of the security as well, and then securing all this password for all the users, it can be cumbersome, right? And then it's just not scalable. And then as with, business nowadays going digital, right? Everything real-time communication. So they deploy more and more SIP endpoints, SIP application servers. It's just not sustainable for the department who actually has to maintain this a SIP footprint. So what actually the motive of this is, to explore alternative, right? Because back in the days, you have like a local user accounts, and then every server you have to log in, and then you have to secure, and then you move on to the next. But we have invented like domain, so why don't we make it a domain? So once you join a domain, once you secure it, so it's a similar concept. Why don't we make a domain, so that we can leverage the expertise and then staff. So let's say one university got hacked, and then this information is useful so that other universities can be proactively prepared. That, I saw this incident, and then let's create a firewall rule so that when the same attacker attack your university or your bank or your organization, you already proactively prepared, right? So this is try to leverage other people's detection for your protection. That's kind of the idea, to leverage their expertise. And it's also to scale and then facilitate the collaboration among this many organizations, because usually the hackers out there, hey, if I were successful with one bank, I'll try another bank, because chances are they use the same vendor, they use the same protocol, they use the same methods, right? Let's explore, right? So the idea is, why don't we work together, create a consortium, right? And then share this threat intelligence among ourselves so that it's useful for us, right? And then, but there is so far today, there is no way for us to collaborate together. So the motivation is to create a framework so that we all can collaborate and then share threat intelligence, be proactive, and scale the operations, securing the SIP infrastructure, okay? So the contribution from this paper is a framework to secure SIP system by leveraging blockchains. So this is the kind of the architecture. Each of these PBX actually owned and operated by independent companies, independent organizations, right? And then you have like a front end and you have a back end. So the front end consists of the firewall to drop the packets, right? And then you have a SIP proxy, can be either commercial SIP proxy servers out there. You can use open source, doesn't really matter. And then you have an IPS that can actually detect what's going on. And then there's this blockchain client scripts. So this is the one that capture the information and send it to the blockchain. So we treat the blockchain up here as like a database as a service. Why didn't we create just a normal database? Well, and then you have like a trust issues. How can I trust you? Because one of the characteristics of blockchain is that it's publicly verifiable. I can see who actually did it, and then it's secured, and then it's There's no single point of failure. So there are great qualities about this. And then I'm not a database person. I want to be able to utilize this for this purpose, right? So front end and back end. So when your PBX get hacked, right? The SIP proxy will be able to detect there's an attack going on, and usually it will write a log, right, in the log file. And then the IPS need to be able to scan the log and pick those up. Hey, something was trying to exploit this account, right? Maybe too many login attempts failed or something like that. And then the blockchain scripts will then capture the source IP address and send it to blockchain, right? And then the other PBXs retrieve this information. Oh, this attacker just attacked the bank over there, right? And then retrieve the IP address and apply it to their firewall. So, and then of course, you know, you have to maintain this, otherwise you'll come up with a very long list of attackers, right? And then if I were the attacker, I can on purpose do this so many times, so that will become a self-inflicted denial of service, because these rules are so long, and then you inadvertently block your own legitimate users, right? So this list has to be maintained. And then one way to do that is by putting like an expiry timeout. You know, for this, once it's failed, you put an expiry timeout, let's say for 1 hour, so that the hacker find it, you know, it's too much time to hack this one. Let's move on to the next target. That's what we are hoping for, right? Because there's not much gain in trying to, because they also do like a ROI analysis, return of investment. If I keep trying this particular PBX, will I be able to get in? And then what can I get out of it, right? So the idea is to put enough barrier, enough time, so that they move on to the next target, okay? So this is the front end layer, the firewall. It is used to drop packets, and the IPS to detect attacks and create firewall rule automatically, right? And then the client scripts to disseminate the IOC, indicator of attackers, and then via blockchain. So this is the attack detection. It's a rule-based log scanning using a regular expression. This is the very SIP proxy specific. So maybe Asterisk has some sort of log format when they detect certain attack, but it's different, you know, to Free Switch, to, you know, Gamaliel, to Cisco, to Avaya, to, you know, Microsoft. They all have a different, but they usually do write something to the log. And then it's also doing a dynamic update, so that to avoid self-inflicted denial of service attack. So like, for example, for Asterisk, right? Every time there is a username or authorization mismatch, it will come up with something like this. So your IPS need to be able to capture this pattern, right? And then automatically write a firewall rule, okay? And then the backend layer is really simple. So it's using a REST API to access blockchain, because otherwise what you'll have to do is to set up your own blockchain node, which is, you know, it's a tall order. You know, I don't want to maintain my own blockchain node and join to the blockchain network. It's just, you know, it's too intense. But of course you have to write a smart contract. A smart contract is basically a code that, you know, a code to access the data, right? So you build a smart contract that basically is a dynamic list of attackers. So that's actually what this smart contract is. And the Ethereum is the blockchain network that supports smart contract, as opposed to, you know, other blockchain network. Okay, so this is the test bed that I did. You know, for the firewall, I use commonly used IP tables. And then for the SIP proxy, I use Asterisk. And for the IPS, I use a fail to ban, which is a very common, comes with many default the Linux distributions out there. And then for the blockchain client scripts, I wrote it in a Node.js. because there are a lot of libraries already available out there that, instead of writing from scratch, just use that. And then I set up like 3 nodes in AWS. One is in US and one in the UK and one in Singapore. So the idea is, let's say the proxy in US got attacked. Let's see how the proxy in Singapore and in UK can learn about this and set up a firewall to proactively, prevent this attack, right? And then I use the Ethereum COVAD, the development network. Okay, so this is kind of the flow, the diagram, right? So this is the attacker. First, it will hit the asterisk, try to probe with wrong username and password. And the fail to ban is you need to be able to detect the log file, the asterisk log file. And then from here, fail to ban, you can write a script to actually add a new rule for the IP tables. So scan the log. Once you found this pattern, create a new firewall rules so that effectively it will block the next packet. So you kind of start dropping packets from here, and then on the back end, it will launch the add IP client script, which will write into the blockchain via Infura. Infura is the REST API that's available for you to use to access blockchain. So that's why Infura is there, because it's very handy. I don't want to maintain my own a blockchain node, right? I just want to make a REST call and the data is there. Okay, and then this SIP proxy in UK and in Singapore, I put like a cron job to run every minute to see is there any additional attackers being reported. So I also have a client script, like a get all JavaScript, to go to this blockchain to see any new attackers detected, basically. Retrieve all. And then once I read it, right, the same thing happened. I parse it out, and then I'll create new rules for my firewall. So that's number 4. So that when the same attacker attack my asterisk, it's already blocked right here. So I learned from what I learned from US, I applied to UK and Singapore. So this can be like a globally synchronized state. I think that's what we want to be able to achieve here. And then the fail to ban also maintain the expiry. So let's say if the account, if after 10 minutes, after 15 minutes, or 60 minutes, right, when it's expired, it will delete the rules from the firewall. And also the same thing happened over here. It will delete the rules to the blockchain. Say, hey, we've blocked this for 1 hour. That's enough. Let's take it off for now. And if it's attacking again, let's put it back on, basically, to make it. So this is like a dynamically maintained. It can grow and expand and shrink, right? So, and the test cases is brute force attack on a SIP1 at US. A couple of wrong username and password, and the new firewall supposed to be created in SIP proxy in UK and Singapore. So the results over here, yeah, this is. Yeah. It's a firewall. Yeah, it's an IP tables rule. Yeah, because when you detect when the asterisk got attacked, right, in the log file, it captures the source IP address where the attack is coming from. Correct. Who is the attacker? So that's the one that being shared, and then you put this into the firewall so that the next packet comes in, you know that this is an attacker. You'll start dropping the packet, and then you share this attacker IP address with the rest of your community. Did that answer your question?
Yeah.
Okay. Okay, so over here, in asterisk found like 3 attempts, right? So it start banning this particular IP address, the 52. This is a AWS public IP address space, right? And then over here in a SIP A, and then this IP tables, normal IP tables rule. And then over here, you can see that is the new firewall rule already installed over here, this source IP address, and then it start rejecting because this has been detected as an attacker's IP address. Okay, and then over here, the blockchain scripts also disseminate this IOC indicator of compromise via blockchain, and it will give you the transaction hash. Yes, this transaction has been committed, and then this is the hash for you. And then this is the input data. You can see that this the same attacker's IP address is captured over here. Okay? And then over at the server in UK and in Singapore, it retrieves this attacker's IP address and then create its own firewall rule. So over here, as you can see, this new firewall rule is created over at in UK, right? And then the time, as I put it, like every minute, a cron job to retrieve. So it's like a 1 minute apart. So over here is 21:28, and over here is 21:29. So you can do it in a pretty timely fashion, right? And then the same attacker attacks this SIP proxy, and then you can see it start dropping packet right over here. So the 43 packets drop coming from this particular attacker's IP address. Yeah. So the conclusion, actually we can actually scale the protection. And one way to do it is to create this framework, a domain where we can share information about the attackers and help your organization to be proactively prepared so that it helps to scale the SIP security staff in your organization. And then together we collaborate, we work together as community to make our environment safer. But is for blockchain itself, right? The ecosystem is under active development, is growing every day, and especially when you write the scripts, what happens is you have to be really careful about what libraries you use, what function calls you use, because these libraries change all the time. You have to make sure it's all line up and it doesn't break, right? Because it's still under active development. But for what it's worth, we can take advantage of the blockchain, right, while mitigating or and recognizing the limitation of it, right? But I think as we move forward, it's a community effort that we want to foster and collaborate together. That's all I have. Thank you very much. Any?